Good morning, everyone. We are Team 6, and we'll be presenting our elderberry processing plant second progress report. I'm Michelle Grauman, and at this time, I would like my team members to introduce themselves.
Howdy, I'm Zach Bankson.
Howdy, I'm Carly Frankowiak.
Austin Ross.
So the agenda of this presentation is to go over flow analysis, potential solutions, decision analysis, selection analysis, and our conclusion. Zach is going to be our next speaker for flow analysis.
All right, so I'm going to give a rundown of the flow analysis for our problem. If you go to the next slide. Once the berries enter the facility, the first thing that's going to happen to them is they need to be washed. The berries come in on the bundle like you see on the tree, so they still have their stems on. They come in those clusters. They're going to be hand washed through some type of water bath. Could be just as simple as a tub. We haven't worked out that particular part just yet. Once they get hand washed, they're going to be air dried over a fan. That'll help with the freezing process, which is next. If you go to the next slide, please. The freezing process, this will help store the berries and also help remove the stems from them. The berries need to be dried and laid out on single layers on a pan. The reason they need to be on single layers is because if you were to store them all clumped together, when they'd get frozen, they would just form a giant frozen mass. What we want is the individual berries to be frozen. We don't want them to be frozen together. Once they're frozen, they will move on to stem removal. If you go to the next slide. The stem removal looks like just a wire rack that runs through what are rubber kind of fingers. The stems will fall through the wires, and the rubber fingers will hold onto the berries and help separate the stems from them. The reason the berries need to be frozen is because it hardens the outer skin of the berry and helps keep them from being crushed or bruised or damaged throughout this process. From the stem removal process, there will be two options. The berries will either continue down the production line or they will return to the freezer for storage. The reason they need to return to the freezer for storage is because the berries themselves have a very, very short shelf life, as in 1 to 2 days. So freezing them extends that shelf life and allows us more time in case we have a backflow of berries. At this process, there's also a possible byproduct that our team is still looking into. Depending upon what we do with the bagasse later on determines whether or not we can use the leftover stems as a byproduct. And go to the next slide. From the stem removal, if the berries are continuing down production, they will enter another water bath. This time the water bath has two different purposes. Not only does this water bath help thaw the berries from the freezing, it also helps us determine which berries are not fit for production. In our system, unripe berries will float to the surface of the water. The reason we need to separate these unripe berries is due to the the toxic content of unripe elderberries. The unripe berries can just be scooped off the top of the water and disposed of, and the ripe berries will be removed and put into what you can see here as a berry juicer. Again, this is something tentative. Our team's still looking into better options for berry juicers, but essentially it's just a mechanical press that will squeeze all the juice out of the berries, and once the juice has been removed and collected, we can take the remaining skins, known as bagasse, and convert them into a value-added product that we're still working on. After the juicing process, you'll notice that at the very bottom there is another diamond that says remove water. The reason that one is a diamond is because that is where our actual potential solutions come in. Our team's potential solutions that we're looking at today focus primarily on the way to concentrate this juice, since that was the most difficult part of the entire process. The actual concentration process will be discussed by, I believe, Carly next.
Thank you, Zach. So I'll be discussing the potential solutions that our group has looked into. And like Zach mentioned, these solutions are mainly focusing on removing the water to produce the concentrate. So the three main solutions we'll be looking at today include vacuum distillation, freeze drying, and applying direct heat. Two other solutions that we briefly have looked into include osmosis, which has been recently suggested by our client, as well as adding a certain chemical to remove water. Those are kind of on the back burner for now. As we look more into how that would apply to the project, we're focusing our energy currently on the first three that I'll be discussing. So, next slide. So the first solution, vacuum distillation, the main purpose of this is to remove the water by adding or by reducing the pressure. And so by reducing the pressure, you're reducing the boiling point of the liquid to separate the water and produce the concentrate. So with this, there's a higher cost associated to buy the vacuum distillation setup. But the goal of reducing the boiling point is to reduce as many antioxidants that would be lost. So as we talked about in our last progress report, the higher the temperature applied to the elderberries, the more antioxidants are depleted or kind of killed off, basically. And so if we can keep the temperature as low as possible, we will maximize the level of antioxidants in the resulting concentrate. And so with this system, the bigger capacity to be more efficient and have more product flowing through would require a bigger vacuum, and as you can imagine, a higher cost. And so, as similarly, a stronger vacuum to reduce the boiling point even more would also have a higher cost. And so that's kind of a setback we're looking at, and to kind of see what would be best for the client. And so pictured is one that we've considered. This is a pretty small scale, and so the client definitely wants a modular system that can grow with the entire system. So the next slide, please. So the second solution is freeze drying. And so in this system, the juice is frozen and water is extracted as a vapor. The water is extracted also using a vacuum, but this is a pretty slow process and would take a couple days in its entirety. But a plus side of this is that it would retain the chemical structure and the antioxidants would not be affected, since there is not as much heat or any heat applied. And so, like I said, longer duration. Same situation here with the cost. The bigger the freeze dryer itself, a higher cost, but it would also improve efficiency because you'd be able to do more concentrate at a time. And so I'm going to pass it over to Austin to discuss our third potential solution.
Yeah, so for our third solution, we're going to use direct heat to remove the toxins from the juice and to concentrate the juice by boiling off the water. Next slide. So the first option for using direct heat is using a heat exchanger or a heat coil, like the picture on the left here. And an advantage to doing that is that it supports a continuous flow through the system, so that the volume of juice through the system can be adjusted based on the supply of elderberries that the facility is getting. And the second option is using large heated processing tanks, such as the one on the right here. An advantage to that is that different sizes of processing tanks can be added or removed from the system based on the supply of elderberries. Our client suggested using a wood-burning rocket stove so that he could use the wood that's on site for heating the juice, and both of these systems would support that. The primary issue with using direct heat is that high temperature destroys the antioxidants in the elderberry juice, but our client suggested just adding ascorbic acid to the concentrate, which is basically vitamin C, to restore the antioxidant value in the concentrate. Next slide. So starting with our decision analysis, we chose 4 items that will be rated on a 1 to 10 scale for each solution. Those items being efficiency, cost, resource, sustainability, and capacity. And we assigned each item a percentage based on what we felt was most important. So efficiency will account for 40%, cost for 30%, and resource sustainability and capacity are both at 15%. So this is our decision matrix, and Michelle is going to go more specifically into each section of this.
Okay, so for our selection analysis for efficiency, efficiency was the preservation of nutrients. So the high score was freeze drying with a excuse me, score of 9 because we have found information that freeze drying preserves 90% of the nutrients. The low score in this section was the heat because the heat temperature creates a 10% loss of antioxidants in the 5 to 10 minute boiling baths that they get put in. The next section was cost, and cost was the overall cost of the system and machinery. And the client has told us we are working with a limited budget, so it is extremely important to keep that in mind. The high score of this section was the heat because of its simplistic design, and the low score was the freeze drying because of all the expensive equipment that goes into it, such as the freezer and the vacuum system. Next was resource sustainability, and this pertains to how materials are obtained and the nearby resource use. The high score was the heat distillation, was the heat because of the availability of nearby resources. Wood is a mentioned resource for us to use, and this is the only solution that will most likely be able to use the wood. The low score was freeze drying because it's harder to obtain the equipment and the processes that go into it. Next, for capacity and speed, it is known that we need to produce 100 pounds of elderberry a day to 1,000 pounds, so we need to be variable in what is produced. The high score was the vacuum distillation because it's a quicker heating process. The low score was freeze drying with a score of 5 because you slowly raise and lower the temperature and it can take a long time. Qualitative factors not shown in the chart are the labor availability. Labor ages range, and then for userability, skilled versus unskilled workers. In Guatemala, you mostly find unskilled workers. So in our implementation plan, we'll be needing to make notes of how the workers will be trained. The next steps are going to be more osmosis research on what the client just informed us about, and we'll be performing an economic analysis. And our next meeting will be on April 1st at 9:45 a.m. And then any questions?
Okay, is the flow of elderberries constant through the system, or does it change?
It is variable.
Okay, maybe one more question or comment?
I really enjoyed the flow chart that Zach was covering in the beginning. I thought it was simple enough to understand, especially for people who don't know what your project's really about. So that was really good on y'all's part.
Hey, Annalie, it sounds like something's covering your microphone. We could hear you, but you were very muffled.
Oh, okay. Do I need to repeat myself?
Yeah, we couldn't pick up what you're saying. You're going to need to work on that before your presentation. You're coming in kind of garbled.
Okay.
That sounds better. Talk to us.
Okay. Well, I was saying that the flow chart was really good. In the beginning that Zach covered.
Yeah, Annalie, we're not able to hear you very well at all. If you have another microphone, you're going to need to switch to that somehow.
Chat, you can write it down.
Or you can chat, but the bigger picture is she has a presentation to do, and that's not going to work.
Connection.
Yeah, you may have how's your internet connection? It may be affecting it. All right, well, you work on that, and let's press on to instructor comments. Dr. Is there a client on board here? Okay, so right to Dr. Castell, go ahead.
Very quickly. So, I was very pleased with the progress of this team. Excellent presentation. I really like how you address the client's comments and it shows that you're communicating very well with your client. I really enjoyed your diagrams. The only thing I would add temperature sometimes to your processes, right? And I agree, I think freeze drying looks good in your decision analysis, but freeze drying is very expensive and it takes too much time. So I will not consider that solution as your final recommendation. I believe the distillation is the most effective in terms of simplicity and cost and everything else. But anyway, you had questions about that, email me and I can guide you better. But I think you did an excellent job with your analysis, the presentations, the description of all the unit operations. I would like to know, for example, what is your target temperature in the vacuum distillation? And this is a nice application on the steam tables that you see in 315. Some of you, I think all of you took that class, so it's excellent. Anyway, excellent job, very good. I'm very pleased, and I will keep my comments short because of the time's sake. But great job, team. To say for everybody. Good job.
Yeah, wow. Yeah, I agree. This was, let's see, your presentation was about 13 minutes long, very equally distributed among the four of you. Austin only had about 2 minutes. Zach took 5. You know, I wish y'all could see my notes pages. I normally use I use up arrows and down arrows to indicate this is good or this is bad. I introduced a new, I guess, emoji on this time. Next to the selection analysis, I put little hearts because that's probably the best selection analysis I've ever seen.
Yes.
So whoever came up with that, I assume, Michelle, that was your brainchild. That was a really good way of communicating that to us. The whole presentation was superb. It was a very good systems approach. Your slides were a good mix of text and pictures. So the selection analysis I liked. I also liked the potential solutions. You had a variety of solutions. They were all independent, where the client could say, you know what, based on your presentation, I like this one right here. Let's go with that one. So I even like the way in your potential solutions you presented the different characteristics. You know, Carly was talking about there's, you know, the vacuum distillation, pressure, boiling point, and antioxidants is an issue. This is going to produce the maximum antioxidants, and the direct heat that Austin talked about is going to produce the least antioxidants. Those are really good characteristics that help you and the client to distinguish between the pros and cons of those solutions. So this was fantastic. Jan, make sure I get a copy of this presentation. I'll probably use it as an example of how to do it next year. My only critical comments in terms of you know, what I've done differently. Let's go, Zach. I really like your flow analysis, the way you took a step through that. I was a little surprised when you got to the go to your last flow analysis slide. So I was a little surprised when you got here and you said, this is where we're going to focus. Now that's good, but that being the case, I'm really not sure why you spent so much time on these other processes. That was interesting, but probably, I don't know. It's hard to be too critical about that. The only thing else I would say is your flow analysis is lacking numbers. I'm looking for, you know, what is the processing rate? In other words, what would be the desired processing rate? How many elderberries do you expect to have to process an hour, a day, or something? Because that's going to determine the size of your solution. And then the equipment you showed here, you know, this is an example, obviously, but what is the capacity of this? And the other thing I was missing was the conveyance from one process to the other. Is it a conveyor belt? Are they hand carried? So, but this is a flow analysis, and you're really focusing on what's going on in the different steps. So that's not too bad. What else? Yeah, I could talk a lot more, but I want to go ahead and get ahead of the game. This is a good presentation, so good job. Any other comments? Young, you want something? No?
No, I'm good. It's a very good presentation.
Yeah, good job, guys.
All right.
Very nice.
Let's change over and get the next team, get their slides up.